Hi everybody, in this video we're going to talk about the greatest common factor, and at the end of the video I want you guys to be able to find the greatest common factor of integers and factor polynomials using the greatest common factor. Okay, so let's first talk about integers, which are just numbers. When we are finding the greatest common factor, it is the largest factor shared between two or more numbers, and a lot of times we're just going to call it the GCF, which stands for greatest common factor. And a factor is just numbers that you multiply together to get another number. So for example, 2 and 3 here are factors of 6. So let's go ahead and look at an example. We want to find the factors of each number, then find the greatest common factor between those two numbers. So when I think about finding factors, I like to do what's called a T-chart, and I like to start with the smallest number and work my way to the largest factor. So what times what would give me 12? I'm going to start with 1 times 12, go to the next number, 2 times 6, and 3 times 4 would give me 12. I know that I'm done with my factors because my next number would be 4. I already used 4, so I'm done. Do the same thing for 16, 1 and 16, 2 and 8. The next number would be 3. 3 cannot go into 16, so go on to the next number, 4. 4 times 4 would give me 16, and then again, because I would start over with 4, I know that I'm done. Now that I have the factors, I'm like, okay, what is the biggest number that they share? Well, the biggest number is 4, so therefore the greatest common factor of 12 and 16 is equal to 4. Sometimes you'll see this notation here, not super important, but if you ever see it, that's how they write it. Okay, so now we can use this idea and talk about polynomials. So when we are factoring our polynomials, it's going to be called factoring by the greatest common factor, and here are these steps. First, we're going to find the common number and the common variables that are shared between each term. Then we're going to divide each term by that greatest common factor, writing the greatest common factor on the outside and leaving what's ever over on the inside of parentheses. So let's go ahead and look at this example. First, we need to look at just our numbers. So between 6 and 12, let's estimate what is the greatest common factor. Well, I know that 6 goes into 12, so I'm going to rewrite 6a squared using 1 times 6, because those are my two factors. And I'm going to write 12 as 2 times 6, because I want to use my greatest common factor between those two numbers. I'm also going to want to try and split up a. So remember, a squared is just a times a. So I'm going to rewrite this as 6 times 1 times a times a. All I did was break it down into its factors. Same thing here, 6 times 2 times a times b. That is the first step. Now I need to see, hey, what do they have in common? Well, they both have a 6. And notice they also both share one A. So I'm going to go ahead and highlight those as well. Whatever you can find in both of those terms, that is what you are going to take out and write once. So I'm going to write the greatest common factor on the outside, the 6 and the A, write a parenthesis, and now essentially you're just going to say, hey, what is left over? Well, I have a 1A here, and I have a 2B here. I'm going to see if I can clean it up a little bit. If there were more than one number or variable on the outside, you could multiply them here. But again, I'm just going to have 6A parenthesis, A plus 2B. And what's nice about this is that you can always check your answer. If you were to distribute the 6A to the A and 2B, you should get your original answer up here. Okay, we have one more. Stick with me. So we also can do this when we have multiple terms like this one, but make sure that when you're finding the greatest common factor, each term has to be divisible by. So I'll talk about what that means first. So again, same process, even though we have 3 terms. Find the greatest number between 12, 15, and 6. Don't worry about that negative yet. So here's my factors of 12, 15, and 6. I look and see the biggest number between them is 3. So that's going to be my number, my greatest common factor. Now let's look at x cubed. I can write x cubed as x times x times x. Similarly, x squared as 2x's multiplied and then just 1. Again, now I'm going to be like, hey, what do they share? They only share one x because this guy over here only has 1 to give. So my greatest common factor is going to be 3x. Now we're going to come back to this negative. We like to take out a negative if this first term is altogether negative. So I'm actually going to take out a negative and just place it out here. We are now going to divide each one of those terms by our greatest common factor. So essentially, I'm just dividing everything by negative 3x. So let's look at this first term. Negative 12 divided by negative 3 gives me a 4. x cubed on top divided by x, that really means you have 3 x's on top and 1 on bottom, so you can cancel only one of them and you'll still have 2 left over on top. So if you need to write this out as x times x times x on top and 1 x on bottom, imagine you canceling those both out and you're left with 2 x's on top, and x times x is x squared. Same thing for this one. 15 divided by a negative 3 would give you a negative 5x. And then the last one, 6 divided by negative 3, gives you a negative 2. Again, both those x's will cancel. And there's your final answer. You're going to leave it just like that. And again, you can always check your answer by taking this negative 3x and distributing it to each term. All right, that is factoring with greatest common factor. If you guys have questions, let me know. If not, I'll see you guys in the next one.